All right, nomenclatures. Ketone alidoses, I think it's called. Nomenclature. Well, I'm not that familiar with it, so I'm not going to pretend like I'm an expert in that. All right. The simplest of the ketones then is where you have one carbon on each of your alkyl groups. Or you could write this as H3COCH3 in that RCOR product form. The functional group here, of course, is this part right here. And the fact that you have two alkyl groups, but this is the carbonyl group, so you have to attach that, you have to attach that, and now we got different Mickey Mouse around there. But the point is, alkyl group plus two different alkyl groups come to it. That's your entire functional group. Doesn't make any difference how many carbons you got. In fact, you have two alkyl groups makes that a ketone. Okay? Now, remember, this is ketone. So the common name, the IUPAC name for this. Again, based upon the longest continuous chain, IUPAC is very consistent with that. I really like IUPAC. The longest continuous chain of carbons here is 3. So this is technically a propane. The oxygen isn't part of the chain. It's attached to the chain, but it's not part of the chain. So the name of this compound is going to have the word propane in it. But the fact that this is a ketone, to demonstrate the fact that this oxygen is turning this into something other than a hydrocarbon, is going to involve the use of this suffix in replacing that E right there. So the name of this compound is propanone. Now, do we need a number to explain where the O-N-E is? No, because if you put the oxygen on the end, that's no longer going to have two alkyl groups coming off. So this is all you need for the IUPAC. Now, the common name is a lot like an ether. At this point, I'm going to redraw this as well so you can see this more clearly than what I've got with the little Mickey Mouse going on up there. So this is what we have. So, like the ether, you identify the alkyl group, that is, not the alkyl, sorry, the functional group, that's your functional for the common name. It's not your functional group for the IUPAC. That's a big difference right there. That's your functional group, so that is your ketone. So the name is going to end with the word ketone, just like the name of the ether is ended with ether. Now you identify the two attachments you have, and I'll make Mickey Mouse's green ears. It'll fall off any minute now. But they're both methyl groups. So the name of this compound is dimethyl ketone. And again, it's 2 words because it's not IUPAC. It's an adjective. Dimethyl is an adjective for the ketone. The grammatical level. But nobody calls it that. They call it something else. And yeah, this is acetone. Everybody calls it acetone. Although I have seen bottles with the name propanone on it, it made me very happy. I'd like to get rid of the acetone because the ACET on there implies something that is not true about this. So, what are you going to do? Ignore it. That's what I like to do. All right. Now, when you get up to, say, like, let's say 5 carbons here, and we're going to put an oxygen right there. This is a ketone because you have two alkyl groups belonging to the carbon, or the carbonyl group rather. So the IUPAC name, as you can see, is 5 carbons right in a row, is propanone. But, and there's always that big but, trust me, I know. You can have the double bond option right there as well. And this is also propanone. Well, holy macaroni, what are we going to do? Well, obviously, for the IUPAC, they came up with a statement that anytime you have ambiguity, numbers are going to have to be involved. So we have to number the carbon which we find our carbonyl. And the carbonyl group is on the second carbon right here. So that's 2 propanone. That's on the third carbon. So that's 3 propanone. Common names. Common name for this? Well, there is your functional group right there. So what you have separated here, a methyl group here and a propyl group there. So that is methyl propyl alphabetical ketone. Methyl propyl ketone. Okay. Common name for this? Well, there's your functional group right there. Divides into 2 ethyl groups. So this is diethyl ketone. Pretty nice. 3 propanone is pretty nice too. Oh, wait, no, not propanone. Oh my goodness. It's 5 carbons. Moron. This is pentanone. How many of you were screaming in the Chromebook on that? It's pentanone, not propanone. Pentanone. Oh my gosh. Not good. Alright. Let's do one or a couple more. Yeah, a couple more here, then we'll be done with this monstrosity. You might actually learn how to count carbons correctly. Let's do this one. This is a dandy. Can't put one there because that gives it 5 lines. And every carbon, remember, has 4 lines. IUPs. Alright, this is where the fun begins. What's the longest continuous chain of carbons in this compound? Well, you can go a number of different ways with this. You go like from here to here, or straight across, or variations thereof. But it's 6 no matter what you do. So this is going to end with hexanone. The question is, do we need a number? Well, if we did for pentanone, not propanone, then we're going to need it for hexanone. So this is going to end with 3 hexanone. So if I isolate that, you can see here, if I make that straight line there, you see you got 2 carbons, one without any hydrogen on it until now. Those are methyl groups. So if this is 3 right here, we have to go in this direction. That means that carbon number 2, that's carbon number 5. That's 2, 5. Dimethyl. And then this is important, hyphens. Some of you are not getting all your hyphens in there. You have numbers in there, it's going to be separated by hyphens. This is all words, you don't have to separate it. Common name. Oh, now this is a doozy. So let's take a trip down memory lane to the alcohols. I'm going to take this 3 carbon piece right over here, and put it over here, and then I'm going to put an OH on it right there. What was the name of that, what was the common name of that alcohol? 3-carbon group with an OH on the first carbon. Well, if you remember, this was isopropyl alcohol. And ethers and ketones both use those common names for their common names of the ketones. So that is called an isopropyl. Now, I'm going to take this one off right here, and I'm going to attach the OH to the carbon that's bonded to the carbon over here. Okay? So that looks like this. I'm going to put the OH there. Remember, HO and OH are the same things because I just want to show that oxygen locked into that carbon, not the hydrogen. Alright? What was the name of that alcohol? Well, you take a look at that chart, that collection that I gave you. This is called isobutyl alcohol. So that means the common name for that attachment to the ketone, your functional group here, is your functional group. This is isobutyl. Now, when we list these and then spin it with the word ketone, we ignore the prefixes, even though they're the same here, but they were different prefixes. Ignore them, just look at the butyl and the propyl, and the butyl would have to go first. So the name of this compound is isobutyl isopropyl ketone. Yeah, it's a fitting. So keep referring back to your alcohols if you're not sure what the attachments look like for the compound. Okay? Alright, now there are reactions to this, and we're going to spend some time in the last section after the amines on dealing with reactions. This gets into involvement with the other alkyl groups, the other carbonyl groups that we have in the remaining 3 groups, which is the next 3 videos that we're going to have. So, we'll come back to that later. This is enough right here for you at this point. You have an assignment that is a practice problem that will be attached to your Google Classroom assignment. So, have fun.